We have been talking about graphs, and we're going to continue talking about graphs as a way to display data. And I want to start just by reviewing a type of graph you probably already know, which is a bar graph. This is an example of a bar graph, and it's a bar graph because we use bars to show the data. For example, this graph shows that there are 9 students who have soccer as their favorite sport, 4 who have softball as their favorite sport, 6 who have basketball as their favorite sport, and 3 who have something else as their favorite sport. So the bars make it very easy to compare and see, for example, that soccer was the most commonly preferred sport, and then there were some things that fell into the other category and things like that. And we're looking at a graph today that is sort of similar to this, but it's a little bit different. It looks similar. This is called a histogram, and it looks similar because it has bars, but the bars touch. And the reason the bars touch is because if we look at this bottom at our x-axis, you're going to notice that these numbers that are here along the bottom are in what's called intervals, meaning, for example, the first interval includes anybody who had M&Ms as their favorite category and was in the age range of 0 to 5. Then the next interval is 6 to 10. So it includes anybody who had M&Ms as their favorite category and was in the age range of 6 to 10, and so forth and so on. So a histogram is a little different than a bar graph because a histogram has one category and then it breaks it up somehow numerically. So for example, the category that is graphed in this example is about people who have M&Ms as their favorite candy. And then it's broken down by age range. If we look at our previous bar graph, it's different, and the way that it's different is because the sports that are along the x-axis are all completely separate, distinct sports. Soccer is different from softball, which is different from basketball, which is different from other sports. But when we look at a histogram, the numbers that are along our x-axis here are all related to one another. They are all ages. They're just all ages that are within a different range. So that's what a histogram is going to be. It's going to be a category of data or a piece of data that is split up into intervals. And it's always going to be split up numerically. And the intervals are always going to be consecutive. So 0 to 5, 6 to 10, 11 to 15, so forth and so on. And the reason the bars touch is because what would you put between 5 and 6? There's nothing to put there. What would you put between 10 and 11? There's nothing between 10 and 11 age-wise. So there's no reason that you would have any space between them. So it shows continuous data. Another way that you could show the continuity of the data is if we look at this graph, for example. This one is about the heights of black cherry trees. And notice here along our x-axis, we're measuring the heights of the trees. Along the y-axis, we're looking at the frequency of that height. But when we look at those heights, what I want you to notice is these are labeled a little bit differently. We start with a 60 here, and then here's 65. So what does the bar here actually mean, that first bar? It refers or includes any tree that is anywhere from 60 feet to 64.9 with bar notation. Basically, anything that is anywhere from exactly 60 feet tall up to, but not including, 65 feet tall. The next one would include any tree that starts at 65 feet tall up to, but not including, 70 feet tall. So we would essentially say 69 and 9/10 with bar notation, so forth and so on. So this is definitely continuous data. So again, the main differences between histograms and bar graphs. A histogram is a type of bar graph whose bars show one category of data and it shows it within intervals. So a histogram shows data in intervals while a bar graph shows data in categories. In a histogram, the bars do touch, and that's because it all shows continuous data. They're all related in that regard. And a bar graph, the bars do not touch. So again, why is it that the bars on a bar graph do not touch, but the bars on a histogram do? Well, it's because on a histogram, there's no space between the intervals. They show continuous data. So let's look at an example of how we could make a histogram. We could use, if we want to make a histogram of the grades that Maggie earned in math class this quarter, it might be helpful to use a frequency table to organize our data before we graph. What I mean by that is if we look at the frequency table here on the right, we can use it to help split our grades up into categories of grades that are between 50 and 59, 60 and 69, 70 and 79, so forth and so on. So as I start working on that, I'm going to say, well, the 90 is between 90 and 99. The 85 is between 80 and 89. The 78 is between 70 and 79. The 55 is between 50 and 59, so forth and so on. So I'm going to continue my frequency table, and when you're done, your frequency table should look like this. You ended up with 3 grades that were between 50 and 59, 2 that were between 60 and 69, 7 that were between 70 and 79, 6 that were between 80 and 89, 6 that were between 90 and 99, and none that were between 100 and 109. So I'm going to go back just a minute and let's take a look at those numbers again, just in case you need to fix your frequency table that you made. Pause if you need to check it, and then when you're done, go ahead and move on. All right, now that you've checked to make sure that your frequency table matches my frequency table, let's go ahead and make our graph. And just like when we did function tables, grades are going to be along my x-axis, frequency is going to be along my y-axis. So I'm going to put grades here at the bottom for my x-axis and frequency for my y-axis. Now, as I make that graph, I want to start labeling my x-axis, and one of the first things I'm going to do is, now we know that when we think about this as being the origin, 0 being the origin, 0, 0 being our origin, then we really should have to go from 0 to 0 to 10, 0 or 0 to 9 rather, then 10 to 19, 20 to 29, so forth and so on. But there's no data until we get up to 50 to 59. So what we can do is we can do a symbol like this, which shows that we're going to sandwich the data from 0 to 49 all up into that where that little mark is on our axis. And then our first interval is going to be from 50 to 59. And our second interval is going to include grades that are from 60 to 69. Our third interval is going to include grades from 70 to 79. Our fourth interval is going to include grades from 80 to 89. And our last interval is going to include grades that are from 90 to 99. Now remember, I want to point out to you that each of my intervals has to be the same size. If you make them a different size, if you make them different sizes, then they're going to be misleading. For example, I wouldn't want to make one interval go from 50 to 69 and then make the next one go from 70 to 74. I want them to all be the same size. So then I'm ready to label my y-axis, and then I can start putting in my data. The highest frequency I have is 7, so this axis it's easy enough counted by ones. 1, 2, 3, 4, 5, 6, and 7. And notice I marked it every one. I only labeled every other one because that's just, to me, is easier to read. But you could label every one if you needed to. That would be okay. You could label every hash mark. And then I'm ready to just make my bars. So 50 to 59 has a frequency of 3. So I'm going to make that bar, so forth and so on. Now, go ahead and finish yours out, and then go to the next slide and check and see how you did. All right, now taking a look, this is an example of my finished graph. Notice it shows the data. It shows the distribution of the data really well. I can see that she most commonly got grades in the 70 to 79 interval or range, and that most of her grades really were somewhere between 70 and 99. Now, this is an awful lot like a dot plot, and I could actually look at a dot plot of that same data. And when I look at a dot plot of that same data, it also shows that the majority of my grades are from 70 to 99, which is the same thing that my histogram showed. But the thing about it is when you look at those two, what I want you to notice is the dot plot will actually give the specific grades, while the histogram will not. Both of them show how the data is distributed, which is really what they're designed to do, and what they do well is they show how the data is distributed. So where is there the most data, where is the least data, things like that. It would show your peaks and your gaps and your clusters. But the difference between them, one of the big differences in the information they show, is that the dot plot will actually show the specific data while the histogram will not. For example, I can tell from the histogram that there are 7 grades that fell in the 70 to 79 range, but I don't know exactly what they were. They could have been all 71s. They could have been all 79s. We don't know. But when we look at the dot plot, you can actually look at it and see the individual data. It would appear that she probably had a 71, a 73, a 74, two 75s, two 78s, and two 78s or 79s maybe. But when you look at that, it shows the exact data instead of simply showing the which interval the data falls in. So the dot plot gives the specific information. The histogram simply gives the intervals. And either one is fine, but in certain situations, one might be better than the other. For example, the dot plot works well when you have a small number of pieces of data, relatively small number of pieces of data that are relatively close together, whereas the histogram works better when you have lots of data, because imagine having to make, say, 1,000 dots. That would be difficult. But on a histogram, it would be pretty easy to show lots of pieces of data. And it still shows then how the data is distributed. So hopefully that gives you an idea of another way that you can show data distribution, and also explains the difference between a histogram and a bar graph.